Hello, Stormworks players. I am a fellow Stormworks player like you. I am not a typical content creator. However, um, I was having a really hard time finding a good tutorial for an autopilot system for a helicopter, and I decided I would work one out myself. This turned into a 3-week endeavor in which I learned how to write Lua code, and I learned a little bit of trigonometry, and I tweaked and tweaked and tweaked values until finally I got something that works. I have tested this on 3 of my own helicopters so far, and it is about as plug and play as it gets. So my goal was to create something you could just put into a helicopter and make it work without hardly any effort. So let me show you guys what I came up with. So you have inputs here and 3 outputs. So you've got the autopilot enable. This is just a button or switch, and the altitude hold enable, which is the same thing. You also have your seat pitch, your pitch angle, your seat yaw, and your compass. Now this all makes sense. It should be pretty self-explanatory. Seat pitch comes from your seat. Pitch angle comes from a tilt sensor facing forward. Seat yaw comes from your yaw from your seat. Compass comes from a compass also facing forward. Now the directions for the tilt sensor and the compass are important. If you mess those up, the math won't work and it won't be mathing anymore. And you might end up somewhere, but it won't be at your target. This just goes out to your collective, out to your pitch, out to your yaw. That's all you need. You don't need roll input or output for this. So you can wire your roll directly to your gyro, or if you have another system to stabilize your roll, that's fine too. But I didn't build it into this because it was complicated enough as it was. You have target X and Y. This comes from a keypad. Make sure that X comes from input A and Y comes from input B. I'll show you what I mean when I get out of this screen. GPS X and Y just come from a GPS. Important note on the GPS, you have to make sure that it is on the outside of the craft. If it's boxed in, like in a compartment, it will not read, and so your craft will fly in a random direction. I assume towards 0, 0, because it's not getting anything from the GPS, but I haven't actually tested that, but that's what makes sense to me. Right, after you have the altitude hold enable, all these are just stuff with your altitude hold. You've got a target altitude, current altitude, and your collective. So the placement of these, I hope, makes sense. It was about as logical as I could get. Now, if you go to the logic itself, I'll just briefly go over. I'm not going to go over a full tutorial. It's pretty complicated. This part is simple, though. This is just an altitude hold. You can watch lots of tutorials on how to build those. This is all of those inputs I mentioned, as well as a couple of property values, which I'll get into in a minute. Going into a Lua script, the script goes out into a debug panel that I'm not currently using, so it's not active, but it was really helpful when I was building it. It also goes into a controller for the pitch and a controller for the yaw. The yaw controller I ended up managing with a PID outside the script. It's also managed with a PID inside. For whatever reason, they work better together, and so I left it alone. There's probably cleaner designs, but if it ain't broke, right? So all of this goes through a switch box, which is switched on and off by the altitude enable, or I'm sorry, the autopilot enable, and seat yaw goes into the off value. If it's activated, all of that goes into effect and it manages the yaw. So pitch, yaw, and collective being the altitude hold, are all that you're using in this. My bad. Okay, now let's go to my little test helicopter. First thing you'll notice is if you click on the microcontroller, you can actually manage some of those values here. This is the proportional and the derivative for the autopilot. I set a maximum pitch angle. The reason the maximum pitch matters is different helicopters can pitch forward by different amounts, and if you pitch forward too far, the altitude hold will not be able to maintain the altitude anymore. So you could test this with your build personally by basically setting a waypoint far enough away that you can observe if your helicopter starts to sink. If it starts to decrease in altitude beyond more than like 2 or 3 meters from what you set it to, then you should probably decrease your maximum pitch angle. Now, if it holds a rock solid altitude, you could probably increase it a bit and get some more speed. But, just tweak it how you see fit. The stopping distance is pretty self-explanatory. How far away from your waypoint are you going to stop pitching? Now, if you set this too small, your helicopter is going to start aggressively spinning in circles around the waypoint. I find around 75 is perfect for this helicopter, but I increase it a little bit because at 75, it will stop pitching forward and it'll drift just far enough that it wants to do a turn, and then it'll stop. And I figure at this, we'll see. I haven't tested it at this, but it'll probably do a little better. And then you've also got the PID values for your altitude hold. All right, so that's the microcontroller. Let's see how it works. So this is just my test helicopter. It's nothing fancy. I'll set an altitude of 100, and I'll set waypoints to, we'll do something relatively close by. We'll just go over the train station. So, like that. One other thing to note is you have trim values for helicopters. A lot of people use them. If you want to trim your helicopter with those, take a note of your trim values for if they're in yaw or if they're in pitch, particularly yaw, and you'll want to put those into a function block where you do x plus whatever your trim value is. If you do this, the trim will continue to work when the autopilot is active. Otherwise, the autopilot might end up fighting your natural rotation. Alright, turn it on, and you'll see immediately we start flying towards the waypoint there. It's pretty rock solid. I've tested it in every conceivable direction. It's important to do that if you're building an autopilot, because if you don't, it might do just fine going east or west, but it might invert north or south, or the other way around. So, it's just part of the testing process. Now let's see what happens. I set it at 100, so when I get over the waypoint, it should just kind of drift to a stop. It might have to cancel the movement out a little bit there. Yep, there we go. And then it should stop. Perfect. Alrighty, that's it. So I did add this autopilot to the workshop. It is just called Helicopter Autopilot. The logo was at the beginning of the video. You can see it. And anybody who wants to is welcome to use it. I do ask that if anybody uses it in their builds, I get some credit for that, because this was really hard to put together. But other than that, get building and have some fun.